Have you ever contemplated whether we're truly alone in the universe? Of course, assuming there's another component to our reality beyond what we can see. Imagine a scenario where the James Webb Telescope finally reveals that we live inside a black hole. Join us as we explore more about this groundbreaking news that will make you question everything you thought you knew about the universe. So, what exactly are black holes? They're like something out of a nightmare. Sure, you might have seen them in sci-fi films, but they're far more terrifying in reality. According to experts, black holes in space are enormous amounts of matter compressed into an incredibly small area. Imagine a star several times larger than the Sun packed into a sphere the size of New York City. The gravitational pull is so intense that nothing, not even light, can escape it. Scientists have been fascinated by black holes for decades. They've studied objects in space so massive and dense that they could trap light. The most well-known concepts about black holes were predicted by Einstein's theory of general relativity. Essentially, when a massive star dies, it leaves behind a dense core. If this core's mass is several times that of the Sun, gravity overwhelms everything, leading to the formation of a black hole. Detecting black holes isn't easy because they emit no light. However, researchers have found ways to infer their presence by observing their effects on nearby matter. For example, if a black hole passes through a cloud of interstellar matter, it pulls the matter toward itself in a process called accretion. Also, when a normal star gets too close to a black hole, it can be destroyed, emitting X-rays as it does so. Black holes also significantly impact their surroundings. They can consume nearby stars, emit powerful energy bursts, and even influence the formation of new stars in some areas, while slowing it down in others. But where do black holes come from? Picture stars, once brilliant and luminous, meeting their ultimate fate in a catastrophic explosion called a supernova. From the remnants of these fallen giants, black holes emerge. Most black holes are born from massive stars that have reached the end of their lives in a supernova explosion. Smaller stars, when they die, turn into what is known as neutron stars, incredibly dense but not dense enough to trap light. However, if a star is several times the mass of our Sun, it collapses under its gravitational pull, forming a black hole. As powerful as these collapses are, something strange happens near their surfaces. Time itself begins to behave oddly. From the perspective of someone far away, time seems to slow down near the event horizon, the point of no return for anything falling into a black hole. It's as if the star's clock ticks at a different speed compared to ours. Occasionally, when two smaller black holes collide, they merge to form a much larger and more terrifying black hole. If a black hole interacts with a neutron star, they create a phenomenon that defies comprehension. Scientists have been grappling with the scale of these massive anomalies for decades. Black holes come in two sizes, small and large. But small is relative when it comes to black holes. The remnants of giant stars can be 10 to 100 times the size of the Sun. There could be as many as 10 million to a billion of them in the Milky Way alone, a staggering number of black holes that could devour anything in their path. However, there's something even more colossal. Supermassive black holes exist at the opposite end of the spectrum. They are millions, if not billions, of times more massive than the Sun. These behemoths reside at the centers of giant galaxies, including our own Milky Way, pulling everything toward them like cosmic vacuums. The renowned physicist Stephen Hawking spoke about black holes throughout his life. His lectures were always insightful, though some of his theories couldn't be confirmed due to a lack of necessary equipment. However, there is hope on the horizon. A single scientific instrument is making a huge difference, and we're not ready for what it may reveal. Enter the James Webb Space Telescope JWST, a marvel of engineering and a testament to human ambition. Previous space telescopes have done a fine job, but this incredible instrument is on another level. Its $10 billion price tag reflects its complexity, requiring the collaboration of NASA, the European Space Agency, and the Canadian Space Agency, along with contributions from over 300 universities. Since its launch, the JWST has achieved countless remarkable feats. It traveled more than 1 million miles to reach its orbit around the Sun, where it will remain indefinitely. During its journey, the telescope successfully deployed its 5-layer sunshield and large primary mirror, which had to be folded to fit onto the launch vehicle. One of the most exciting moments came when NASA announced that the telescope had captured its first images of starlight. The first image taken was of a star called HD 8446, producing a mosaic of 18 scattered bright spots. These came from the star's light being captured by the 18 mirror segments on the primary mirror. The JWST will allow scientists to examine the early stages of the universe after the Big Bang, focusing on what happened after the first stars formed. It will help researchers understand how galaxies evolved and reveal more about the mysterious nature of black holes. Most importantly, the James Webb Space Telescope will help answer the most fundamental questions of all. Are we alone in the universe? And could we be living inside a black hole? The JWST has already been on the hunt, and guess what it found? Polycyclic aromatic hydrocarbons, PAHs, lurking around supermassive black holes in 3 active galaxies. These carbon-based molecules with ring-like structures are found throughout the universe, from distant galaxies to comets in our solar system. They're not just interesting because they could be the building blocks of life, but also because they help astronomers track star formation. When ultraviolet radiation hits these PAHs, they glow and emit infrared light, a signal that the JWST's mid-infrared instrument MIRI can detect. This light often indicates the presence of hot, young stars nearby. But here's the twist. Astrophysicist Ismail Garcia-Bernit from Oxford University decided to study 3 active galaxies, known as NGC 6552, NGC 7319, part of the famous Stephan's Quintet, and NGC 7469. These galaxies are millions of light-years away in the depths of space. What Garcia-Bernit discovered was astonishing. In the central regions where supermassive black holes dominate, he found a mass of PAHs. But here's where it gets chilling. The intense radiation near these black holes distorted the PAHs, transforming them into larger, electrically neutral versions of themselves, while the smaller, charged PAHs disintegrated into nothingness. Imagine being consumed by the very darkness surrounding you. But wait, there's a deeper question here. Could this mean that black holes aren't just cosmic vacuums, but something more complex? What if the universe itself is a result of the strange, incomprehensible forces within a black hole? The ultimate question isn't just whether we are alone, but whether we truly exist at all. Could everything we know be happening inside a black hole's event horizon, the boundary where space and time distort beyond recognition? The James Webb Space Telescope is only beginning its mission, yet it has already opened doors to possibilities we never imagined. As it peers deeper into the universe, it might not only change what we know but redefine what we thought was possible. The mystery of black holes, the origins of the universe, and the potential for life beyond Earth are questions we may soon be closer to answering. If we truly exist within a black hole's event horizon, reality as we know it would be drastically different from what we perceive. The event horizon is the boundary where gravity becomes so intense that even light cannot escape. Inside this region, space and time warp in unimaginable ways. Some scientists have proposed that the entire universe could be the interior of a massive black hole, a mind-bending idea rooted in the laws of physics and cosmology. This theory stems from the notion that the universe began with a singularity, an infinitely dense point from which the Big Bang occurred. Interestingly, singularities are also found at the centers of black holes. Could the Big Bang itself have been the formation of a black hole in another universe, spilling its contents into what we now experience as our universe? Moreover, if we are inside a black hole, the edges of the universe might correspond to the black hole's event horizon. The cosmic expansion we observe could be the result of the black hole's continuous growth as it accumulates more matter from its parent universe. The role of the James Webb Space Telescope. The James Webb Space Telescope may hold the key to answering such profound questions. Its ability to see back to the universe's earliest moments could reveal clues about the nature of the Big Bang itself. By observing the first galaxies and stars, scientists hope to understand whether the universe's structure aligns with the predictions made by black hole cosmology theories. Additionally, JWST's ability to detect faint signals and subtle distortions in space-time could help identify signs of gravitational waves and other cosmic phenomena linked to black holes. These observations could strengthen the case for the universe as a black hole hypothesis. The search for life beyond Earth, while exploring the farthest reaches of the universe, the JWST is also investigating exoplanets, planets outside our solar system, in search of habitable worlds. It can analyze the atmospheres of these distant planets by studying how starlight filters through them, looking for signs of water, oxygen, and even potential biological activity. The recent discovery of PAHs near black holes raises intriguing possibilities about the building blocks of life existing even in the most hostile environments. If life-related molecules can survive near the universe's most destructive forces, life might be more resilient and widespread than we ever imagined. A new era of discovery. With each new image and dataset, the James Webb Space Telescope pushes the boundaries of human understanding. It has already revealed galaxies from the universe's infancy, discovered strange exoplanets, and offered unprecedented views of celestial phenomena. However, the deeper it looks, the more questions arise. What is the true nature of reality? Is the universe finite or infinite? Are we products of a cosmic accident or part of a grand design? As the JWST continues its mission, we may one day find answers to these questions, or encounter mysteries far beyond our current comprehension. The journey to uncover the secrets of black holes, the universe's origins, and the possibility of life elsewhere is only beginning.